In this session, we are discussing about combinational circuits. The combinational circuit is a circuit in which we combine the different gates. For example, encoder, decoder, multiplexer, and demultiplexer. Some of the characteristics of the combinational circuits are the output of the combinational circuit at any instant of time depends only on the present input terminals. The combinational circuit do not use any memory elements. So that is the previous state of the input does not affect the present state of the circuit. A combinational circuit can have n number of inputs and m number of outputs. This is the block diagram of combinational circuit. The first combinational circuit is off-adder. Off-adder is a combinational circuit which adds two input bits and it produces two output bits. So for the off-adder, we have two input bits, that is A and B, and we have the two outputs, that is sum and carry. So since it considers the two inputs, so the combinations are 0, 0, 0, 1, 1, 0, 1, 1. So just by adding 0, 0, 0, 1, 1, 0, 1, 1, we will get the values of sum and carry. So the sum value is equals to 0, 1, 1, 0, and the carry value is 0, 0, 0, 1. So if you are writing the expressions for the sum and carry, sum represents A XOR B and carry represents A and B. Similarly, we have one more combinational circuit which performs the addition of 3 bits. And this circuit is called as full adder. And full adder is developed to overcome the disadvantages of the off-adder circuits. So here it can add two 1-bit numbers along with the carry. So the full adder contains 3 inputs A, B and carry, and it produces the two outputs, one is sum and another is carry. So since it contains the 3 inputs, we have 8 combinations. And 0 plus 0 plus 0, whereas the sum value is 0 and even the carry value is 0. Suppose if we consider the combination as 0, 1, 1. So 0 plus 1 plus 1. So which produces the value as the sum value is equals to 0 and the carry value is equals to 1. So similarly, if it is 1, 1, 1, 1 plus 1 plus 1. It produces the values such as sum is equals to 1 and carry is equals to 1. So if you are writing the expression for the sum is equals to A XOR B XOR C. And the carry can be determined by taking the sum of AB, AC plus B. So C is equals to AB plus AC plus BC. Similarly, the next and the most important of the combinational circuit is multiplexer. The multiplexer contains n data input lines and 1 output lines, and it also contains m selection lines. It is a digital circuit which selects one of the n data input lines and it routes to the output. The selection of the one input line can be done by using these selection lines. Depending upon the digital code applied at the selected inputs, one of the n data sources is selected and it is transmitted to the single output. So because of this reason, the multiplexer can be widely used in C, and that is computer networks. And the multiplexer can also be considered as data selector. And along with these input, output and selection lines, even it contains one strobe or enable input, which can be useful to cascade several multiplexers together. It is generally an active low terminal. That means it performs the required operations when it is low. So this is the block diagram of multiplexer. So as already we've seen that multiplexer contains n data input lines, that is from data to the n minus 1, and it contains one enable input pin, and it contains the m selection lines and a single output. And always the number of selection lines can be determined by taking or by writing this number of input lines in terms of two powers. And whatever the power value we are getting, that power value will be equals to the number of selection lines. And the size of the multiplexer can be written as 2 by 1 multiplexer, 4 by 1 multiplexer, 16 by 1 or 32 by 1. So whereas this 2, 4, 16, 32 represents number of input lines. Suppose if you consider the multiplexer such as 16 by 1 multiplexer. So it contains 16 input lines and 1 output line, and by writing this 16 in terms of 2 powers, its value is equals to 2 power 4, and that 4 can represent the number of selection lines. And we'll see one example how to implement the Boolean function by using multiplexer. Suppose if the Boolean function is f of a, b, c, d is equals to 0, 1, 2, 3, 4, 8, 9, 15. So this number represents the midterms of the Boolean function. And this function we have to implement by using 8 by 1 multiplexers. So here the function itself contains the 4 variables, but we have to develop this function by using 8 by 1 multiplexers. So to implement this 4 variable function by using 8 by 1 multiplexer, so 3 variables can be considered as the selection variables and 1 can be considered as data input lines. So in this example, B, C, D variables are used as the selection lines and A is used as the data input line. So first, to implement this function, we should draw this particular table. Whereas the first row represents the A dash, that is A value is equals to 0, and the second row represents the A value is equals to 1. So here we are writing the minterms in which the A value is 0. Right. So the first 8 minterms will comes to the first row, and the second group of 8 minterms will comes to the second row where the A value is equals to 1. So 0 to 7 can be written in the first row, 8 to 15 can be written in the second row. So after writing these minterms, so now whatever the minterms which are presented in the function, those minterms must be circled. And so now based on these circles, now we have to determine the function in terms of this. So if both are circled, we have to consider the input as 1. If both are not circled, we have to consider the input as 0. If the first row is circled, we should consider the row value represents, that is A dash. If the second row contains the circle, so then you should consider the respect A value, that is A. Right. So now we'll see. So here this Boolean function contains the midterms such as 0, 1, 2, 3, 4, 8, 9, 15. So first we circle those midterms. So if we consider the first one 0, 8, both are circled. So you should give the input line as 1. So the same we had applied. So even in the second column both are circled. So we should write down the input value as 1. And in the third row, both are not circled, so we have to apply the input value as 0. Next, in the fourth one, the first row value is circled, so we should consider the A dash. Similarly, for the next combination, we should write down A dash. Next, so the same thing we had connected at I3 and I4. So in the next one, both are not circled, so the input is. In the next one, both are not circled, so the input is 0. And in the last combination, the second row is circled. So we should consider A value. So In this way, we can implement the Boolean functions by using multiplexers. And the next combinational circuit is decoder. A decoder is a combinational circuit. It has n inputs and maximum, that is 2 power n outputs. Decoder is identical to the demultiplexers without any data inputs. It performs the operations which are exactly opposite to those of the encoders. So this is the block diagram of decoder where it considers n input lines and m output lines. Suppose if you have 2 by 4 decoder, so it contains 2 input lines and 4 output lines. And this is the truth table of this decoder. So in the decoder at any time only one output value is equals to 1. So if the input combination is 0, the D naught value is equals to 1 and all the remaining outputs will be equals to 0. So if it is the combination of 0, 1, only D1 is equals to 1 and the remaining output values are zeros. So similarly for the 0, 1, only the D2 value is equals to 1 and for the 1, 1, D3 value is equals to 1. Encoder. Encoder is a combinational circuit which is designed to perform the inverse operations of the decoder. So the encoder has a n number of input lines and m number of output. Thanks for listening to class.